window, either go to that URL, click on that URL, or what you do, simply you copy paste all the things, these scripts which I shared it in the chat window, right? Put it in a notepad. So what you do is, look here in the chat window, whatever is there, just simply right click, copy this and put it in a notepad. For the time being, that's it, you are done. This is to demonstrate how the many to many, what is a bridge table, all the things. Okay, today we'll start with something, a different topic. As part of RDBMS only we are going to talk, but still it is going to be related with the normalization, all the things. Just give me a second. Yes, Srinivas, just now started. Srinivas, I just shared the link in the chat window. You click on that link. You can download that script. So download the script will take time. Better what you do, right, Srinivas and others, you just copy paste the script, whatever I shared it in the chat window. Copy the script. Either you can copy paste in notepad or you can paste it in the SSMS itself. In the SSMS, what you do, here you find the new query here. So can you all of you see this one, the new query here? So this is what the new query button. You just click on the new query button. Click on the new query button and then paste the script which I shared it in the chat window. That's it. Okay, and what you do is you just click on this and save this as some meaningful name, many to many SQL. This is another way of many to many, this is for the many to, how to handle the many to many related thing. Okay, go to some folder, right? So here I'm going to save this as a many to many one.sql. Okay, are you sending? I cannot see. Oh, you're not able to see it. Just let me just resend it. Not a problem. I'll just right click and copy it, and in the chat window, I just share it to everyone once again. I think everyone should be able to see the script. Srinivas, can you see the script in the chat window? Just confirm it in the chat window. Or else, best thing what you do, you just go to this link. This link also will share it here. Okay, you go to this link. Click on the link which I shared it to you all. GitHub link. So here what you do is, so what I do is, going forward, I'll send all these instructions well ahead. You alone. Okay, please, it is boring watching the 2-hour video. Student course. Yes, till select star from student course. Till okay, you copied that one. Select star from, yes, till this one it is enough. Okay, till this one. Yes, Srinivas also confirmed. So till this one is enough. Okay, and the case when and all you can ignore it. Okay, and up to this, if you do it, that is more than sufficient. Okay, just a quick recap on what we discussed in the last session. We just discussed how to create a table. Yeah, we have discussed about the, one second, someone asked something. It's done. 1 year is done. Very good. Thanks for updating that. So yeah, we have something called data definition language. So DDL stands for data definition language. And number 2 is DML, data manipulation language. data manipulation language. So what are the things that falls under DDL? One second, I just use the comment. How do you specify comment for a single line? You can use double hash, the same double line, the same command or the same notation that you use it in Power BI also to specify the single line comment. So this is a single line comment, data definition language. When you execute this one, the SQL engine, when it comes to this first line, and if it finds double hash, it will not execute the whatever you typed followed by this double hash. The SQL engine, whenever it encounters the double hash, it will understand, hey, this line I don't have to execute it. This is a comment. So double hash is single line comment, and multi-line comment is this one, like in C language and other language, right? We use this kind of notation. So data definition language. So what is the data definition language? Create table or create database, and what are the other, one second, sorry, create database. And today I will start this one without file. Create database, alter database, create, alter. So create database, table, right? And then create index, all the objects. What are the objects? Objects are something like table, database, and view. We have something called view, and we have something called trigger, right? So trigger, or let me, I'll talk about trigger later. Okay, alter database, the same thing. So once you create the database or table, if you wanted to alter it later point in time, you can alter it. What do you mean by alter it? So once you create the table, or after you create the table, if you want to make changes to your table, for example, you wanted to add a new column in the existing table, so you can use alter database, alter table, alter table. If you want to rename your database, you can use alter database. Similarly, create, alter, drop. So alter database and drop database, everything on the alter command itself, it is possible. Okay, yeah, sorry, here alter. So there is a command called alter, using which you can modify the database. In the sense, you can rename the database, and you can add a new column to a table, and you can you can modify an index, or you can modify a view, or you can drop a database or table. Okay, all the objects you can do it in single line. I mentioned everything. Using alter command, you can do all these things. Data definition language. Data manipulation language, here what we do is here data manipulation, what we do is insert. We insert the data into table. Insert, update, and delete. So these are the things that we do it as part of data manipulation language. You understood? So we have discussed, we have seen it, how to create a database in the GUI, and we did not use any command, I guess, right? So we can use a command also to create a database. The syntax is same, create database, create database, something like let's say finance, something like that. I want to create a finance database, finance, select everything, click on execute. This one will create a new database. Let us see what happens. Look here, commands completed successfully. Completion time is this one. So that you are able to create a database. And let us see if I want to drop a database. I don't want to use the database. Okay, I just want to drop the database. Drop database, finance. Completed successfully. Look here, the database got dropped now. And if you go and execute this one, so refresh this one, you will find only one database here, sales. As of now, we could see only one database. I just recreate it once again, create database. In the meantime, you can also create it. So the moment when you select this command and when you click on execute, you find this message, commands completed successfully, then your database got created successfully. but on the left side you need to check whether this database finance is available. It is not there. You need to always refresh it. Finance, right? Why it is highlighting something like this? Okay, or let me do one thing. I think it would have got created in the system database. No, I created it again, right? So master, yeah, once again, yeah, maybe Srinivas, like you said, right? I'll create it once again. I did not execute this, right? Okay, let me just click on this. Yes, you are correct. So I was under the impression I executed this one. Look here, first step is do this one. Don't do the second one. Second command is very dangerous command. First of all, you will not have a privilege to drop a database. Okay, as a developer, you will not, in the real-time scenario, when you work in a development project or any project, you will not have access to this command at all. Okay, so this is a very dangerous command, including drop table, drop index, all these commands, drop anything, drop is very dangerous. Don't ever use it, just for your understanding sake, right? For theory purpose, I just covered this alter database. Okay, and now we have created a database, and probably alter database finance. This syntax is little bit different. I wanted to modify the database. How do I modify the database? So we can use alter database, as I mentioned earlier, right? So you can use alter database, and here you need to specify a little bit, modify name, alter database finance, and modify name, modify underscore name, or modify space name is equivalent to your new database name is like finance smart, something like that. Okay, let us see if I go and execute. Let us see if this works. Very good, it is working fine. And now we will go and refresh it on the left side to check whether yes, it has been got renamed successfully from finance to finance smart. Okay, so now I'm able to rename my database. So I just put the comment how to rename a database. This is to create the database. You don't need any comment. Okay, so if you want to drop a comment, drop a database, you don't need it, you can drop it. Okay, but don't ever use this command. Okay, the same way we can see, instead of this is the command line using SQL query, how we can, or using the data definition language like create, alter, drop, we can do all these kind of thing. Okay, similarly we can create a table, we can modify the table later point in time to rename it, or if you want to rename a column which is part of a table, that is also possible. Lot of bunch of commands are available. Okay, instead of using commands, you can rely on the GUI part. Okay, just point and click, and then you make some changes wherever it is required. That is the advantage of using SSMS. For example, if I want to go here, I want to rename the table, you can you have an option here, rename, in the contextual menu. And if you want to rename any column, you just right click on it, you have something called rename here, and you have modify option is available. This is what in the last session we discussed. Here you can modify the column name itself. We can rename the column name. The column name is not correct, right? So you can wrongly, mistakenly you've given some name, and so you want to rename the column, you can go and rename it. Data type, if you want to modify it, you can modify it. You can change the constraints also. Null constraint, we discussed about null constraint, all these things, right? So remember all these things. So using GUI, we can alter the table, alter the database, we can drop the table, we can drop the database, but don't ever use drop for anything. Okay, don't ever use it. Okay, instead you create some other, rename, or you can create some other database, something like that. Okay, if you don't want this database, you rename it. Okay, you rename it with something. Finance, you can hold finance, something like that. Okay, so that let it be that, right? So because once you drop it, it's a nightmare. So we real time scenario, one of our developer, he dropped a table. It caused major havoc. We ended up postponing the release, code migration, everything. Okay, that's a major issue. Fine. So this is called data definition language, and you can use the commands or scripts to create a database, create a table, create view, everything, and you can modify it. So these are the scripts. How to use scripts to create, or modify, or delete, all these things you can do. Drop, everything you can do it. And in table also, right, you can do it this way, create table, something like that. I just show you that one also. Let me make it fast. Create table. So as I have shown you, I just pick up this query, right? So this one creates, look here, this is the thing, right? So already I have used this. I don't know, in the interest of time, I just do copy paste, create it, because time is very critical now. So we are in the second session, we are in the third session, right? Create table. So this is how the third word. So okay, fine. So this is the data. So create table. Okay, later point in time, for example, if I click execute here, the table already exists. The student table already exists. So I'm not. So what I am going to do is, for you people to understand, drop table student. First I am going to drop this table student. Okay, now the table got dropped. Now I just want to create a fresh one. For example, the column name, I just give it as DOB1 purposefully, so that later point in time I just want to modify it. I just go and refresh it on the left side to make sure that the tables got created successfully or not. Look here, the table got created. Drop table got created. If you click on column, you just click on this column, and if you want, you can rename it here. Okay, you can rename it here, DOB. You can just remove this and you can do it, or else what you do is this one, alter table student, and you have something called what I will do is, I'll just go to docs.microsoft.com. So for you people to understand the syntax, everything, it is always not possible because I worked in different databases. Here what I do is TSQL. This is very much helpful. SQL and TSQL, T-SQL. This is the site. If you want, I will share it in the chat window. You just store it somewhere. Okay, and you store it somewhere so that it will be helpful. So filter by title here, alter table, something like that. Alter table, transact SQL. You can find the bigger script. Okay, a lot of options will be there. Most of the options like the partition, scheme name, these are all related to your either the database administrator. You don't have to learn so many things. Okay, just understand the core of this one. In the interview, you can expect maximum 5 to 8% of the questions only. But from the job aspect, yes, you should be knowing the SQL queries. Alter table, look here, alter table, they've given alter table here, transact SQL examples. You just click on this one. Memory based, disk based, also create alter table, table name, add a column. If you want to add a column, and if you want to alter table, insert into, select, alter table, add, we have something called modify. So alter table, rebuild with. So a lot of options are. You don't have to learn everything. It's all the database administrator's job. Okay. So we have something called, so how do we modify alter table? Yeah, I think what I remember is the modify column. 1 second. So alter table student. Here's something called modify column, modify column, or else let us do one thing. I know this one DOB1, and the data type is date time. If you want to change it to date time, you can change it to date time. Let me see if this command works. Syntax here, modify. Okay, this is modify column. This is related to MySQL and SQL server. You need to check it in the manual only. Let me just go here and see it in the manual. Okay, here alter table name. Sorry, here you need to spell no table, alter column. Alter table name and student. Next one is alter column DOB1 data type. Okay, so here they've given, instead of modify, they've given, look here it is. If you want to change the data type, you can change it like this, and you can modify the column name, alter column, right? So I don't remember the command. Let me just check here. So this is how you can change the data type. Okay, or else let me just go here and right click here. Let me do one thing. I just click here and script table as drop to and select insert update create to drop to. Okay, here it is not the right. So modify, it's not available, it seems, right? Modifying the column name. Column in SQL server, right click. See, they've given this one only, right? So rename columns. I think rename columns will be there, correct? Okay, so you need to use this kind of command. Okay, there's somewhere, right, it is different. So dbo log time, something like that. SP rename, it's not a straightforward way. That's why learning the TSQL is different from SP underscore rename stored procedure. So built-in stored procedure that is available already. Rename your data table name, right? So table name, what is the table name? Student dot DOB1 to something like this. Need to use single quote. Now he is giving that, right? So new name and sys name. So the SP rename object name, and then object name, new name, sys name, object name. Okay, here did not give anything example here, right? Error date time, so column. So here what I do is, let me do one thing. Student DOB. So I just say column. Good, break script stored procedures. Okay, let us do one thing. Now I just SP columns, execute SP columns. When I give this, which was table name, right? So okay, SP columns parameter table name. Okay, the execute SP column student at student. Yeah. Or else I just go and refresh it here. columns, look here, it got renamed. Okay, so I thought of viewing it here itself using some command. So sp rename command is helpful to rename the column. So dob1 to dob, we are able to rename it. Okay, I just save it. This is very much helpful. How to rename a column? So using sp rename, how to rename a column. So create a table, drop a table, all the things. The next one is the data manipulation language. I just go to this one in the interest of time. Look here. So this is the one, insert into statement, right? So if you want to insert the data, you can insert it. Since this table already has some data in it, what I do is I just go and check student, press F5. It is nothing is there, very good. So what I am going to do is I am going to insert this data into that table. Click on execute. Yes, now I just want to, now I am able to insert the data successfully into this table student. This is the one I created it, and then I renamed the column dob1 to dob. Everything is good. So we made some structural changes here, right? So the alter table is used to make some structural changes, including the sp rename. If you want to rename a column, you can use this one to rename it. So now we inserted the data. Now we are not going to, okay, we wanted to change the value here. So instead of giving 2 here, I mentioned 1 here. Let us assume that way. So I want to rename, or I want to replace 1 by 2. How do I do that? I want to make some changes to my data, not to the structure. Here we made changes to the structure. Here what we did, using alter table, we are able to change the data type from date to date time. Date is different, date time is different. We discussed in the last session. And also we have renamed the column itself from dob1 to dob. We made structural changes using this one and this one. We made changes to the structure, but here we are making changes to the data itself. So values 1, I want to use something called update command. Update student and update set. You have something called set command. I just use all the caps letter. Student set. So what is this one? One is student ID. You need to specify student. You don't have to type the entire name, just type this one. Student ID is equivalent to 2, and where, this is what I discussed in the last session. I still remember it. Where class is very much important whenever you use update. So where is very much important in SQL, the select statement, update statement, delete also. You need to be very, very careful. where student ID is equivalent to 1. So what I am saying here is the existing student ID 1, you change it to 2. So the update is a keyword and student is a table name. Set is also a keyword and student ID is the which column you want to, in which column, right? And or which the value in which column you want to modify it. The value 1 that is part of my student ID column. I want to rename, I want to replace this by 2. So the older one is 1. Here this is very much important. Otherwise what will happen is, for example, in the interest of time, I just go and pick up this query here. I just come here and I just put it here, something like this. Here I did not specify primary key. Let us not get into that confusion now. I just say, something like this. I just execute it and then I just fire this query. click on exit, sorry. Srinivas, 2 records are available. Srinivas data is still remain ID is 1 because I did not execute this one, I guess. Okay, 1 second. When I execute this, now if I select star from student, look here, Srinivas student ID got modified from 1 to 2. Previously, yes, student ID was 1. Now I was able to rename it. But had I specified the student ID column, look here, I just keep this and also next to this one so that you can refer it quickly. Look here I define student ID, but I did not specify this as a primary key. If this was a primary key column, then we will not be, you wouldn't be allowed to, use the update statement to modify the, you cannot, modify the primary key column values. Okay, since I did not specify any values here, primary key, all the things, right? So in that case, what I did, I'm allowed to modify not only this column. If you want to modify other things also, for example, so if I want to modify a value in a single column, fine. If I want to modify value in more than one column using a single update statement, how can I do that? For example, here I say, so for Radha, the student ID, I want to change Radha student ID to 4, and also I want to change the student name. Press enter is equivalent to, let's say I say Radha, something like Radha Ravi, right? So where student ID is equivalent to, student ID is equivalent to 3. Okay, if you execute this one, what will happen? There is no student ID by the name of 1 is available here. This update statement will fail. Okay, before we talking about failure scenario, I'll just show you how to update more than one column in a single update statement. So in this case, student ID is 3. So for this record, student ID 3, so we are going to rename the Radha by Radha Ravi, and then we are going to change the student ID as 4. Okay, 3 to 4, Radha to Radha Ravi. Okay, in single SQL query you can do it. So here you need to be cautious here. So look here, when you execute this one, and then if I fire this query here, I just copy paste it here so that if I share the script, you can also practice it. So Radha, right? So the ID, student ID from 4, right? From this is the Radha, right? So 3 to 4 it got replaced, modified, and Radha to Radha Ravi it got renamed. But this where class is very much important. So if I want to rename or rename somebody's name, some customer name, or if I want to rename the salary, or if I want to not rename, if I want to modify, the numeric variable value, right? So let's say you have something called salary. I want to change the salary of Radha Ravi, right? So you can modify, but you need to specify this one, to which employee I need to modify the salary. To which employee you need to modify the salary. So what changes you make it, you need to specify the column names, right? Followed by the set, you need to specify the column, which all columns you want to make changes, to whom you want to make, right? That is what you need, in which table you need to do it. So that's what update followed by the table name, and the columns which you need to make changes, you need to specify followed by set, the where to which record you wanted to modify it. Fine. So here the student ID is 4 now, and student name is Radha Ravi. Let's say if I say 5 years, something like that. Okay, and here first of all we don't have student ID 1 here. So here where student ID 1, non-existing record, I'm trying to update it. So it is still saying that correct, and when I execute it, nothing has happened, right? Nothing has happened because there is no value of 1 for the student ID is already existing in my table, right? It is not available. Hence, though it succeeds, when it comes to syntax, there is no mistake here. So instead of comma, if you put hyphen, then it is syntax issue. You have follow, use the syntax correctly. What is the syntax here? So this is the syntax here. I just specify the syntax is update. This is your table name. Specify the table name and set, and then here you need to specify the column name is equivalent to value. Right, so and then where class is also optional, but when it comes to real-time scenario, you need to make sure that you are specifying column, otherwise the whole table will get changed. This is the syntax. If I wanted to specify, if I want to write column name 1, so you come to value 1. So again, so if you want to specify more than one column, right, if you want to change it, simply specify this one. You don't want to specify set multiple time. Column name 2, value 2. So now you understood. In one liner you are able to understand. See, if I go by the manual, it takes a lot of time. So I'm using some shortcut way of doing this, okay, to help you to cover more and to make sure that you are able to pick up fast, okay. So now once you are done, as and when you make changes, it's always a good practice, right? You need to query this and check it, and also use the where class here also, where student ID student is for our student name, right? So because we did not, or you can check the student name ID itself, right? Student ID is equivalent to 2 or something like that. So if you look at this specific row alone, you are interested in viewing only the specific row, hence better you can use the where. In the where condition, you specify the filtering criteria. So in what sequence the query will get executed? If somebody is asking you, select list of columns, column 1, you specify all the column 1, column 2, etc., right? So whichever columns that you wanted, you can select the list of columns, okay, and then what you do is from class, followed the from, you need to specify the table name. So table name, from which table, which columns that you want to select it, and based on which condition, the filtering criteria, where age is greater than 18, only 18 years people above 18, they are eligible to do stock trading. So in that kind of situation, you can use this one, where age is equal to age. So where it's a filter condition, right? It's a filtering criteria, something like that. Filter where condition, the condition can be more than one column also. You can use the logical operators like and, or, not, in, exists, those kind of filtering thing that you can use it, okay. So this is the sequence that we executed. In the case of aggregation, what we do is we use something called group by. We'll look at the aggregation little later. Let's go step by step. First, you understood how to create a database. Now you are done, and then you want to create the table, right? So before you create the table, it is always a good practice you specify your database. Now in my case, I'm going to use the sales database itself. Use sales, drop table student, create table, and alter table, and how to do this one. Now you understood. The next one is, this is just for your reference, don't execute this. Okay, update, how to modify the values. Next, delete statement. We'll see how we can delete the record. Instead of update, I'm going to use a statement called delete. So the delete, update, these are all called your data manipulation language. Where, that's all, right? Delete student and delete from, or delete in SQL Server. Yeah, it is getting 0 rows affected, which means there is no student exists with the ID 1, hence it was not able to delete. Look here, when I executed it, 0 rows affected. So you need to keep an eye here also, whether it is deleting the record or not. See, the command, it was not throwing an error, that doesn't mean it is correct, right? There is two things. One is the syntax error and semantical error, right? Syntax error, we can identify, it will throw error here, but this is kind of a semantic. Logically we made a mistake. There is no student as a student ID 1 here. When we try to do this one, since there are no syntax error, it is getting executed successfully, no error. That doesn't mean it is correct. There is semantic issue. So student ID is 1. First of all, there is no student exists with this ID. Okay, and okay, now what we will do is I'm going to select the second one is student ID. Let's say 4. I just select this. You can press F5 or else you can go and click on execute. Look here, 1 row affected, which means 1 row got deleted. I just go and click on this. Look here, the student ID 4, right? That entire record got deleted from the student table. So after you deleted this, if you go and check it, yes, we are sure, the record which we want to delete it, we are able to delete it successfully. So in the where class, you can specify more than one condition also. Even in the update also, right? In the filtering criteria, you can specify more than one condition also. So next one is what I am going to do is we have something called the null. So next I will show you one more thing. I just go back here and insert a new record with a null value. Here I say 4 and here I say something like Deepak. Here I say the date of birth as null here. What is null? Null is nothing, okay? It's a blank value kind of thing, okay? So here I just go and click on, I'm going to execute this one. 1 row got affected. So look here, that means 1 row got inserted. To verify that, it is always a best practice, query and check it. Yes, Deepak, and his date of birth is not available because in the form he did not fill the date of birth. So hence you can put something like this. And we will try other command here. Will it work? Will this work here? F5. It says the column or number of supplied values does not match table definition. In the table, we have 3 columns. While inserting it, you inserted only the 2 values. Hence, it is throwing an error. But, I have a requirement, something like in my table, I have 100 columns are there. We don't want to insert all the 100 columns, or we don't get all the 100 columns values upfront in some cases. You just think that way. Okay, there are some cases we get the 50% of the column details, we'll get it later. In that case, if the SQL query is not, the insert statement is not allowing me to do that, it is not much helpful. So in that kind of situation, partially if you want to insert it, you can use something like this. You need to specify the column name. Only these 2 columns I wanted to insert it. Now I just go and execute this one. 1 row affected, and now I just go and select it. Look here, Venkatesh, the record for Venkatesh got inserted here. The way how we inserted the record here and here is different. Look here, I did not specify the null explicitly. This is one way advantages this one, because in my table I have 25 columns are there. All the 25 columns I don't get values. Let's say I just get values only for 6 columns. Just specify the column names here. Column 1, column 2, student ID, student name, or remaining 4 columns. Values you specified here. If you want to insert values only to specific columns, it is possible. But if you have another column, let's say the date of birth, we have another column called date of birth. If this is a not null constraint, had I mentioned not null here, right? So, and if you try to insert, it will throw an error. It will throw an error. So in that case, all the not null column you need to specify it here. Okay, all the not null columns you need to specify it here. So though you are allowed to insert values into a table, though you are allowed to insert values into specific columns in a table, but those specific columns should cover all the not null columns. Right? Though apart from the specific columns, if you have any other column which has a not null constraint defined, right, it will not allow you to insert. Hope you understood this one. Now I just go and select this one, student where. So earlier I used student ID as a filtering criteria. Now what I do is I just go and say where DOB is null. Let me just select this one, student.dob, right? So where it should be correct only, right? So it is correct. Where date of birth is null. It is not working here. Let me just check. Yeah, this is not actually, this is null. Is the correct one. DOB is null. Where okay, maybe I am not using the proper use sales. Okay. Student.dob, right? So student, something I made a mistake here. Student.dob. Student underscore ID is also coming here, and here I just renamed this column, right? Student.dob, student ID, student.dob. Oh, okay, it got changed to something else. Student.dob, student.dob. Let me just, so in this kind of situation you just rely on this one, okay, student.dob, right? So okay, it is their part of this, and without that also you can do it. Yes, you need to use the square bracket here, student.dob. This is something dot, when you use dot, right, something strange here. Okay, student.dob. Whenever you use dot, you need to use the square bracket. Whenever we have any blank space between the column name, we use it. This is somewhat different here. Okay, so in this case, okay, so student ID. So what I am going to do is, so where is null. the SQL server is a bit different from other TSQL commands. Okay, look here, with this you are able to understand the naming convention itself, they are using different way. From select star from student where student DOB is null. So based on this condition, you select whichever student's date of birth I did not specify it in the table. I want that data. So these two students, we don't have the date of birth. So in the case of insurance, the date of birth is very, very important. So if you are automobile insurance, if you are working as part of automobile insurance company, right? So the age of the vehicle, instead of date of birth, age of the vehicle. Even medical insurance, the age of the patient is very much important, because higher the age, the premium, the premium amount is very high, right? So in that kind of thing, right? These kind of queries can help you to find out. As a data analyst, you should be knowing, right? So you need to do deeper analysis. If you know more commands, right? Like is null is a kind of operator using which you can find out, based on null values. I want to know if any missing values are there in a specific column, right? Related to that, if you want to select those records, you can use this one, is null, not is null, something like that. Not is null, the opposite. Incorrect syntax near the, okay, here, see, look here. So not, everything is different. It is completely different from the SQL query. Yeah, is not null, right? So you need to change it. Yeah, is not null. The MySQL not is null, but here you need to put not in between. That's all. This is opposite. Okay, is null. The is not null is opposite of this one. Okay, now you understood. How you can use various operator or something like that, right? So operators to check is null, is not null. How you can you check it, and then what else we can do. So yeah, so now you understood at a high level the data manipulation language, how to insert the data and how to modify the data which we already inserted, right? Specific record or specific column, if you want to modify it, you can modify it. And if you wanted to if you want to delete a record, specific record, you can use delete command. Okay, and you can use more than one condition also in the where clause for the update or something like that. Next one is the create table as, I am not sure, create table emp2 as select star from student 2 as select star incorrect syntax near the, okay, here it is little bit different, right? So create table ctas, we call the ctas command. So what we do is in the case of real-time scenario, we don't drop the table. Instead what we do is we will be taking a back of the table like this, create table student 2, right? So all the values from your student table will get pushed to this one. This is correct only, create table syntax is correct, right? Create table as select star from, so select star. Okay, something wrong here. Okay, let me do one thing here. I just go to the Microsoft site. So create table as you can have something like duplicate tables, right? So duplicate tables, transact SQL new character. So here what he says is you can go here and duplicate, create to something like that, right? So here he says script tables as create to new file and drop to create to. Here it is not much helpful, right? So insert, update, delete. So even for insert, update, delete, all this you can generate the script directly here, okay? But still, if you learn the script, it is always good. And the CTAS, so you need to use something like with, it seems, create table. That one seems to be more of a SQL administrator job. One second, let me just. Incorrect syntax near distribution. With the distribution is equivalent to. So let me just check any syntax here. We call the CTAS create table as select star from. Look here, it is available here. Table as, what is CTAS? Create table as select. So what he is doing, right? Select into test table, and then what test table? Okay, simple. Okay, his way of doing is little pretty different compared to other thing. One second, even I forgot this one. He says into. This is available in other SQL programming, into test table, something like that. So from some name, from student. Yeah. So now select star from test table. The CTAS is not straightforward, it is little bit different. So this is called CTAS. This kind of thing probably you can ignore. This one seems to be more of a DBA job. Let us ignore that one at this moment. CTAS is create table. You just want to duplicate the table, or let's say you want to duplicate the table. How to duplicate the table? So how to copy the existing table to a new table? You can use this CTAS command. So update all the things. So the next one is how to create view. So what is a view? View is kind of a virtual table. In Power BI, we have something called filter function, calculate table function. These functions behind the scene, it creates a virtual table. And similarly, here also the same thing. So we already created a table by the name of student. Let me just. So these are the columns are there. For example, I just want to create view, and what I do is create view stored something like, okay, stored view. Select student name, from student. Student debug, invalid column name. Okay, let me just remove this for the time being. First, let us check if this one is correct syntactically. Create view as the column name, right? So from T go, the same thing I've used it here. Create view name as select, what did you mention? As select column name from table. It's correct only, right? Let me just put it here. Okay, I used the column name, value, everything here. Product ID, value. Okay. And this is insert into T values. Okay, let me just use it here for reference purpose. Create table, create view name as, okay, select product ID, student name from this in value, catalog description, okay, as, yeah, from student. It's correct only, right? So I don't know why it's not getting created. Okay, it got created. Maybe the line problem from student. So let me do one thing. I just select star from stud view, home F5. Look here, I created a view here. The view is a virtual table, so it means it is kind of a pointer to my student table. In the student table, I have 3 columns are there. I don't want to expose all the 3 columns to the other users. For security reason, we create views. Okay, we don't want the user to view all the columns. Okay, from the security point of view, view. So views based on a table, right? So you can create a view based on a table. That's all. If you want to drop a view, you can drop it. So drop view, stud view, and if you select F5, it will get dropped. And if you want to select this one once again, nothing will be there. So here also you can use the where condition, everything. Okay, so with that you can do it. Next one is, we will see the basic, these are the basic thing. Okay, I just jump into now the important concept, the normalization. Okay, in RDBMS, when it comes to relational database management, you should be knowing the normalization concept. What is a normalization? It is a database design technique. Normalization is a database design technique. So in this case, what we do is, as part of normalization, we divide the larger table into smaller tables and links them using relationship. We divide the, basically we call this a decompose. We compose the tables. Instead of storing all the data into a single table, we split the data and store it into different tables, right? Logically. Okay, we will see how the normalization works. So first of all, why we need to do normalization? We want to eliminate data redundancy. We want to eliminate data redundancy. For that purpose, we do normalization, and also we want to improve the data integrity, and also to overcome the undesirable characters, something like insert anomaly, update and deletion anomalies. For that purpose, we have to do normalization. Okay. So for example, here I have something like delete from employee where student group and beta alpha PSI. So what will happen in this case is, to, let's say the employee ID is 1, 2, 3, right? So beta alpha PSI and beta alpha PSI. Here okay, if I want to delete a student, right, from this group, let's say we have recruited students as part of the campus interview. Okay, so we assign them initially to these 2 groups. Okay, so this student can be part of this group and this student, but end of the day, once you onboard the students to your company, the freshers, you give some training for first 1 month or 2 month, 3 month. After 3 months, the induction period, right? So once the training program is over, the 3 months training program, this group is no longer required. If you delete the group, what will happen? If you delete the group, you want to delete the group, but this employee is now moved to the 1 2 3. So this employee number and this employee number also will get deleted from this record. You want to delete the group, you delete the group, but don't delete the employee ID. But still they are employee, right? 3 months training is over. Now they are, maybe we absorbed them as a full-time employee now after 3 months, right? So or initially you want to give them 3 months training, and then you want to assign them to a project or a department. Currently they got assigned to, this guy got assigned to accounting, this guy got assigned to CAS. But if you delete, but this group is not, no longer required, because, as part of this group only we inducted people initially to train them. If you want to delete it, what will happen? The entire record will get deleted, including the employee ID, name, everything will get deleted. So we don't want that to, deleted. Since you are storing all the data in a single table, these kind of anomalies can happen. Okay, these kind of anomalies can happen. So to overcome that, what we do is, we have something like insert anomaly, update anomaly, delete anomaly. To overcome this, one of this delete anomaly. If I delete, I won't delete only this group, not the employee ID, right? Employee ID records, I don't want to remove this employee ID. This is called delete anomaly. And likewise, we have something called insert anomaly and update anomaly. So I will discuss this a little later, okay? So to overcome these kind of anomalies, what we do is, for that purpose also, we are going to split the tables into more than one table. But we don't do it arbitrarily. So for that, we have to follow some rules. That is what normalization. So as part of normalization, right? So the three normalization you need to do it. First normal form, second normal, third normal form. The first normal form, what it says, to make your table normalized, right? So you need to follow three process: first normal form, second normal form, third normal form. So only if a table or a data model design follows these three normal form, we call that as a normalized table. All rows must be unique. Each cell must contain atomic value. The first normal form dictates all the rows must be unique. You should not have duplicate values, and each column you need to have only one value in it. For example, in this case, John fries Coke, and it violates the first normal form. All rows must be unique. Look here, John, we can see that John record is duplicated, right? More than one time his record is there. And also each column, in this column, we could see more than one value got stored. This is against the first normal form. So how do we address that? We can remove this one, right? So fries and Coke, to make it unique. First normal form, right? Or the first rule is all rows must be unique. So remove this record, so that you are addressing one issue. And next one is, you want to store this separately. So in that case, what will happen? You will end up creating the table like this. One second. So what you are doing is, you are splitting this table into two different tables. One is the order ID and customer name. So that is what we have seen. Okay. So in addition to that, I'm going to have the order ID. Order ID can help us to uniquely identify which orders raised by which customer. That we will get to know that. So in this case, okay, John is there more than one time, but still he ordered the product with two different order ID. So in that case, we cannot say it is a duplicate record. So if you literally go by this, yes, I can blindly remove this one. But there are situations, right? The same customer, he would have ordered the same items at different point in time with different order ID. Right? In that kind of situation, what we do is, the order ID and customer name, we group it together into a single table, and then this is the one violating the normal form. By introducing the order ID, we are making sure that the rows are unique. The order ID is the unique value, right? We don't see again the one is repeating here, isn't it? So the order ID is the unique value. So order ID, by introducing order ID, we made sure that the records are unique, and also we are splitting this one and putting it in a separate table. Fries, Coke, all the thing, but still it is not making any sense. If I store all the products purchased by this, these customers, right? But still I wanted to know which products purchased in which order ID. So what we do is, for these two tables, I'm going to include the order ID here also along with this, right? So now you understood, in the case of first normal form, the record should be unique. By introducing order ID, we made sure that records are unique, but still it violating the first normal form, because in this column we have more than one value stored here. Hence what we do is, we remove this column from this table. Simply remove that column, put it in a separate thing. But if I wanted to logically link these two one, I need to have the order ID here, right? So we cannot use the customer name here, because customer name is not unique here, whereas the order ID is unique here. So you bring in the order ID here. Good. We brought the order ID, but here you can have the duplicate values here, right, with this order ID, right? So you have something like parent. This is your parent and child, right? For a single order ID, two products this guy John ordered, and for this order ID two, this guy Mike ordered two products, right? With this you can join those two things. Okay. So now it is in first normal form. The rows are unique and each column has single value in it. Right? But when we looked at initially, right, we saw the records like this, right? This is not a normal form. So we need to use this rules, and we need to make sure that the tables, whatever we designed it. Initially we saw only one table, right? We saw something like this. Everything in the Excel, they gave it to you something like this. It is not in the normal form. You are the database architect. They are the one responsible for doing the data model design. As part of the data model design, you are supposed to do the normalization. So as part of normalization, there are three steps. One is in order to say your table is normalized, it should comply with first normal form, second normal form, third normal form. First normal form, in order to comply with the first normal form, we ended up splitting a single table into two different tables, and we logically related these two things, because the order ID is the common, right? With this we can refer back here. So now it is in form. The next one is second normal form. What is second normal form? Okay, though it is meeting the first normal form, or it is adhering to the first normal form, it doesn't mean everything is perfect, right? So the next one is the second normal form. On top, what they say, apart from this, in order to make sure that your table is normalized, it should follow, in addition to the first normal form, it should follow this one also. No partial dependency. The database must be in first normal form, and also all non-key columns must be fully functionally dependent on the key column. Look here, I took another example here, student ID and course ID and course fee. All the non-key column, look here, what is the non-key column? Must be fully functionally dependent on the key column. So this is the student ID is the key column, and the course fee and course ID is also a key column, but course fee is fully dependent on course ID, whereas the course fee is not fully dependent on the student ID. If I know the course ID, if I know the course ID, I will know the course fee, isn't it? Hence, the course fee is directly fully depend on the course ID. It does not depend on the student ID. So hence we split this table into two parts. One is student and course ID, will keep it separately. So this is a non-key column. These are the key columns, right? So what I am going to do is, student ID, course ID separate, and course ID and course fee I will keep it in a separate table. To link these two tables, the common column between these two tables are course ID. Look here. So right, with this we can create a relationship between these two. And if somebody is asking you student ID, right, what are the courses taken by student ID, right? Student ID, and in this case he has taken the course ID 1, and same student he took course ID 2. So the corresponding fee is 500 and 1000. And again, if you see here, anybody else, this guy student ID is different from student ID 1, and this guy, he also took the course 1. So for him also, for course 1, the fee is 500. For this also, the course fee is 500. Now you understood how to do the second normal form. So this is supposing your table, let's say the customer has given you the table, something like that. So you need to make sure that, the all non-key columns, these are the key columns. Whenever you see something like ID, key, these are the key columns. And this is a non-key column. Course fee is not a key column, right? It can have duplicate values, right? But in this case, you need to apply this second normal form rule. So is this non-key column fully dependent on which column? It is fully dependent on this column. Then why do I need to have this column here? So these two, put it separately, and these two, keep it separately, so that you can refer it back. So right, so both tables do not have any partial dependency. Now it is in second normal form. Good. In addition to first normal and second normal form, your normalization technique should add to the third normal form also. That's what I mentioned. The database must be in first and second normal form, and there should not be any transitive partial dependency. So all columns must be fully determined by the primary key, not by other keys. Okay, any non-key column depend on other non-key column, right? So non-key field. So there should not be any non-key column depend on another non-key column. Let's say we are given another data set, something like this. You have something like employee ID is the key column here, and okay, here something wrong here. So let me do one thing here. In this case, right? Employee zip, whatever is there. Yeah, same thing. Now it is corrected. So this is the data set given to you. This non-key column should not depend on non-key column. So now we can make out the employee zip kind. The employee ID is the key column, right? So this one is a non-key column. This is not the primary key, right? This is the primary key, and this is not the primary key. And even the state is also not a primary key. City is, these are all non-key columns. But if you see here, the city is a non-key column, and it is depending on the another non-key column, district, right? Chennai belongs to Chennai, and Bangalore belongs to Gwalior, belongs to Ratan district, something like that. Okay, so we don't want the non-key column should depend on them. So in this case, the state, right? Chennai belongs to Tamil Nadu state, and Bangalore belongs to Karnataka, and Gwalior belongs to Madhya Pradesh. Right? So it is depending on these columns. The non-key column depends on another non-key column. Hence, what we do is we we keep all the non-key columns which depends on other, right, in a separate table. So if you look at this one, logically it is correct. The state, city, district, all these non-key column is depending on the zip code, right? So zip here, and then see this table we are splitting into two pieces: employee ID, employee name, employee zip. That's all. And then rest we are splitting it from year to year, right? So that's what we have done it. This is called third normal form. So here the employee state, the city, district columns transitively depend on the employee zip, right? So zip column. So even this column is not a non-key column, right? It is all transitively depending on this one. We don't want that to, even this column also depends on another, but end of the day all these three columns are transitively depending on this. This is a non-key column. Okay. So how about others? Devi says she could not hear me. Is that applicable to you all? Hello. Yeah, Srinivas can hear. One second. Yes, Srinivas, can you explain what is non-key column? So in this one, employee ID is the unique value, right? So this is the unique value. This is a key column, right? Employee name is non-key column, and even employee zip. Zip is kind of, right? It's a, here also, but when it comes to this table, right, we cannot say it is a key column, right? So key column, but these columns are non-key column, though these three columns are completely non-key column, but still it is depending on another column. If I say employees of Tamil Nadu, right, this zip is zip, so this column, these columns, non-key columns, are depending on another non-key column. Yeah, key column is unique column. Yes, key column is unique column. Primary key column, right? Yes, Srinivas, you are correct. Srinivas' question is key column means unique column. Yes, that is what. So employed is a unique column, right? So this one will have only unique value in it, whereas this is not having unique value. Here also we don't see any unique value, but still all these other values belong to, I call this, since this is not having a unique value here, right? So these values or these columns are having non-unique values, non-key columns, okay, and even this also non-key column, but all these three non-key columns depends on this non-key column, right? So hence what we do is we will combine all these things in a separate table, because these three columns completely depending on this one, right? We keep it separate and we keep it separate here. Right? So fully functionally dependent is, that is what the second normal form, fully functional, all the non-key columns. So this is a non-key column. Here we don't have the unique value. Here we have something like unique value. We can say composite primary key, right? So 1 is a primary key, composite primary key. Primary key or unique key. Unique key can be a the combination of more than one column also, right? Look here. So these two columns put together, we can identify. For example, student, if somebody is asking you, student 1 has taken, which all the courses. So if you combine these two columns as part of your primary key column, right, what will happen? You can say the student ID 1 is taking 2 courses here. But if you say student ID alone as a primary key, what will happen? You are, duplicating the same value here. It is violating the primary key, it is a violation of primary key constraint, right? You cannot have the duplicate ID. So now to overcome that, we have combined these two columns as a composite primary key. So the student ID 1 and course ID 1, but the same student ID can repeat here, because with the combination of these two only we can determine we can identify row uniquely. Student ID 1 has taken the course 2, and again 1 2 should not come here. Again 1 should not come here. Okay, so since it is a composite primary key, right, so this is the key column, but this column is a non-key column because we see the non-unique values here, and also it is fully functionally dependent on this one, though course fee is indirectly depends on the student ID also, right? Sorry, not student ID, course ID is not depends on the student ID, right? But student ID, with student ID also we can find out the course fee, but it is not the direct way of doing it. It is not fully functionally dependent on the student ID, but it is fully functionally dependent on this one. So in this table, these two are composite primary key. With this composite primary key, only you can identify what courses taken by which student, right? Fine. So what in this case what happened? What is the fully, since the course fee is not fully dependent on the student ID, we are splitting this and pushing it in another table. But if you put the course fee alone separately in another table, how will you know for which course ID which course fee? So for that, what we will do is we will put the course ID also along with the course fee, so that if I ask you a question, right, what is how much course fee paid by student ID? So the 1 will be matched here, right? So 1. So this one, the course ID and course ID got linked here. So student ID 1 has taken not only course ID 1, he has taken course ID 2 also. So for these two course ID, what is the fees? 500 plus 1,500. We can answer these kind of questions. If I ask you a question, how much fee paid by the student ID 1? So you can with the help of course ID, you can create the relationship between these two tables, and then to answer to this query, right, you can tell pretty simple way, right? So right, so in this case, the composite primary key. Not all the time. Don't think primary key you can create only on a single column. This is the primary key. In this case, it is a primary key. In this case, if I put 1 again, it is violating the constraint, right? A unique value, right? This key column. It is violating the key column. Key column in the sense, you just think it is a primary key column in this case. Okay, is it clear or not? Basically, we are splitting this table into more than one table, right? If I in this case, right, we are splitting this because with this we are able to tell very clearly, right? So student 1 is taken, for example, later point in time. Let's later point in time, 1 second. If you store it something like this, what will happen is, let's say you don't let's say you discontinued course ID 1. Okay, if you don't split this into two different tables, what will happen? So that's what I'm talking now. So that's where the deletion anomaly, insert anomaly, update anomalies are coming into picture. For example, so you might be asking this question, hey, why should I split these tables into two different tables? Okay, the rule and all fine. If I don't split, what will happen? Let's say you discontinued course ID recently. Hence, you wanted to remove the course ID from your database. If you remove the course ID, what will happen? Including the student ID, it will get deleted. Course fee is fine. If the course fees get deleted, fine, because the course ID itself, we discontinued it. But the student ID will also get deleted. We don't want that to happen, isn't it? But if you look at this table here, if I delete the course ID 1, because we discontinued it now, but still the student ID will remain as it is. Right? Maybe it will come and check here, this course ID 1 is not there. Okay, it will not return anything, right? It is not showing anything, right? It is not having anything here. If you want to do, so in this case, the deletion, we need to keep that in mind, to avoid the redundant data storage, and also to address these kind of anomalies like deletion anomaly, insertion anomaly, update anomaly, right? So what we do is we split the tables into more than one table. The classic example, delete anomaly. If you store the data like this, later point in time, you want to discontinue the course ID 1 because you did not get the trainer, you want to remove it. You removed it. When you remove it, what will happen? The entire record will get removed. But the student ID 1 and 2 is still, they are taking up other training courses with you, right? Simply if you say, delete course ID 1, what will happen? This entire record will get deleted, right? We don't want that to happen, right? So in this case, if it deletes, this record will still be there, or probably, right, we later point in time we can say in the past he has taken these are the courses, right? Still that record you can get it from here. And the next one is no transitive dependencies. All columns must be fully determined by the primary key, not by other keys. So look here, the employee ID, right? Look here, the Tamil Nadu, Chennai, right? The city, district, employee state. These are not fully determined by the primary key, right? So with primary key, can we identify the state, city, and district? No, right? With primary key, you cannot identify this fully, right? So in that case, the zip number, with zip number, you can identify which city, which location in a city, and which district, which state, you can identify with the help of employee zip. Hence, these columns are non-key columns, and it is not depending on any other non-key column. Employee name is nowhere, same employee name, more than one employee can have the same employee name, right? So in that case, we cannot say employee name is a non-key column. It is not depending on other non-key column, but whereas these non-key columns are depending on one another, but especially these three non-key columns are depending on the employee zip. So within the same, in Chennai city itself, you say 20, it is Adayar, right? In Bangalore, it is something like Bashveshwar Nagar, right? So these, these things are, since these things are depending on this one, all the non-key columns depend on the other non-key column. What we did, we just simply splitted this and put it in a separate table. So only when when your data model design added to all these three normal form, we can say that your database is fully normalized. Next, we'll take a look at one-to-one relationship. So types of relationship: one-to-one relationship, one-to-many relationship, many-to-one relationship, many-to-one relationship. What is the example for one-to-one relationship? One-to-one relationship, the classic example is Aadhaar number. Aadhaar number. Across the India, if you go to any place, each citizen can have only one Aadhaar number. Right? Each citizen. Aadhaar number can have only one citizen name. Each citizen can have only one Aadhaar number. This is called the classic example for one-to-one relationship. Give me an example for one-to-many relationship. Let's say you are working in a software company, Capgemini, or you are working for Infosys or somewhere, right? One-to-many. Let's say Srinivas. Srinivas is an employee. He is working in more than one project, right? So he is working for, he is working for Walmart, and he is working for some other Costco. So 50% is billable here, and he is 50% is billable here, right? So or let's say 40% and 10% he is doing some kind of project management. So one-to-many relationship. Other example is a single manufacturer can produce different models of a car. One-to-many relationship, right? An employee can work with more than one project. There's another example, one-to-many relationship. Many-to-one relationship. What is many-to-one relationship? Give me an example for this. The same opposite, right? So this one, something like single employee can work on more than, or this one, the product, right? Product or an order, right? Many order, right? More than one order. We sold something one-to-many. Yeah. So this opposite, right? So okay, this is single employee can work on more than one project, and many-to-one. Can someone tell me what is that? So I got some idea here. What is that? Nike manufactures shoes, rackets, and costume, right? Yes, yeah. So that one is, correct, right? A single product. No, what you are saying is Srinivas. Nike manufactures shoes. Manufacturer, right? So many, right? Manufacturer, Nike manufacturer, right? So he manufacture more than one product, many-to-one, right? So many-to-one is each project, right? I say many-to-one is each product, more than one employee is working on it, something like that. More than one employee, right? So let's say you have something called something Walmart project, right? Some many-to-one, right? Many employees, right? Many employees, more than one employees. More than one employee is working in Walmart project. We can say that, right? More than one employee, like Srinivas, right? Srinivas, Ashok, more than one employee is working on a single project. The opposite, a single employee is working on, this is one-to-many. You got it? Okay. Many-to-many relationship is something like this. Product and customer. Product and customer, many-to-many relationship. So what does it say? A single product can be purchased by more than, something like MN, right? So both of them are many. A single product, like you said, Nike product, Nike shoes, but purchased by Srinivas and Deepak and so on, Nike product, right? And each customer, right? So single product purchased by more than one, but Srinivas, he purchased more than one product also. Not only he purchased Nike, and also he purchased something like Adidas shoes and some other shoes he purchased. A single customer can purchase more than one product. Each product can be purchased by more than one customer. The many-to-one relationship is this one. More employees, right? More than one employee is working on a single project. A single employee can work on more than one project. Other number, right? So one-to-one relationship. These are the example for one-to-one, one-to-many, many-to-one relationship and many-to-many relationship. So these are all pretty straightforward. What do we, Srinivas has a single company manufactures more than one item, right? So many to one, single company, no, more than one supplier can work for a manufacturer, right? That is what many to one. Yeah, yes, Srinivas, right? So more than one supplier supplies the raw material to a single manufacturing. That is another example, many to one. Multiple suppliers or a single manufacturer. That's another example. Okay. Next one is many to one. So this one is, I think most of you are able to understand many to many relationship, right? So this one, product customer, is the classic example. More than 10 students are very good, right? So more than 10, not more than 10 students, right? Good observation. More than 10 students attend your class. That is many to one relationship. Okay, right? So next one is, yeah, many to many relationship. See, everything is fine. The one to one relationship is pretty straightforward, right? So, and this one to many is fine, and many to one is fine. But many to many relationship, we need to treat it, requires some kind of treatment. Many to one requires some kind of treatment. What kind of treatment? So we cannot implement directly the many to many relationship, and it requires some kind of treatment. Okay, in the case of data warehousing, you will often come across this kind of scenarios, many to many relationship. We discussed as part of cross filter in Power BI, and anyhow, here we have different groups of people. They are yet to attend Power BI. As part of cross filter, I explained about this. I don't know if you remember this. Okay, anyhow, I will explain it for the sake of others. For example, you have the student table here, and you have the course table. A single student can take more than one course, and a single course can be attended by more than one student. So this is another example for many to many. Right? More than one student can take up a single course, or a single course. Or more than one student would have taken a single course, or a single course can be taken by more than one student also, right? So it is a many to many relationship. Or many students, many side. This is also many side, right? So many students would have taken many courses, something like that. Multiple records are there here, right? Here, right? So many to many relationship. So in this kind of situation, how we are going to deal with this? It requires some kind of treatment. For example, if I ask you to select the student name, or print or display the student name along with that the course name, how will you do that? So in order to select, I told you at the outset of this SQL training, I told you what is relationship management is all about, right? So what is relational database management system? What kind of example I gave you? Deepak, why don't you tell me what is? I just unmute you all. Let us probably, we can start interact now. So what is relationship database management system? Why we need to create relationship between tables? If I wanted to select the data from more than one table, in this case 2 tables, I want to select the data from these 2 tables, right? Like a student name and course name. I need to create a relationship between these 2 tables. Can you guys tell me, are there any common column exists between these 2 tables to create a relationship? No, right? No. We don't have any common column exists between these 2. So what can we do? Can I copy the course ID and put it here? If I put course ID here, what will happen? If I put this column here, this is Srinivas, he has taken course 1, and Radha has taken course 1, and Deepak has taken course 2, and Srinivas, in addition, he has taken course 2 also. If I put the course ID here, what will happen? Is this okay? 1, 2. Can you put it like this? Radha, can you tell me? Let me see how well you people are observing here.
It breaks the normalization form, like uniqueness won't be there. So first normal form it breaks.
Uniqueness. No, uniqueness is there, right? Still
No,
look here,
you said
one uniqueness is there, right?
No, uniquely identify each row. Okay, okay, sorry. No, not.
No, you are somewhere close. Okay, you are somewhere close. Right. So uniqueness is there, but using student ID. Let's say student ID is the unique key here. So the unique unique each row should be uniquely identified. Fine. But what is the other rule as per of first normal form which I discussed it?
I think
Each column should have atomic
non-key
value.
should not depend on the
No, 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 no,
column.
no. First normal form itself, we have one more rule, two rules. First rule, in first normal form, there are two rules. Other one is all the rows should be unique, and another rule as per the first normal form is each value in the column should be atomic. Atomic means you cannot have more than one value, right? You cannot store something like course ID 1, comma course ID 2, right? You cannot put in a single column like this. Either you can put 1 or 2. So in that case, what will happen? Srinivas taken course 1 and 1 Srinivas and date of birth and course ID 2. Okay. So in this case, what happens? Yes, probably you can create some kind of composite key. Student ID and course ID. But what happens is Srinivas date of birth, it repeats more than once. Redundancy. Right? It violates first normal form. What is the first normal form? All rows should be unique, and then the values should be values in each column should be atomic. Don't get scared if I say atomic. Atomic is nothing but single value. So here you should have 1 or 2, not 1 comma 2. It is against it is violating this rule, right? It is violating this rule. So hence, to overcome this issue, okay, I just put 1 year and course ID here. I make this a composite key, but here again you need to put 1 year. Fine, but 1 comma 2 is different from 1 comma 1. Hence, it is a unique row. But the Srinivas date of birth, again you are repeating redundancy. It violating the normal form and also redundant, right? Redundancy. It introduces some kind of redundancy. If you store the value Srinivas date of birth, this is Srinivas taken 10 courses and you need to put 10 rows, right? In order to address this, to add it to the first normal form, you need to put 10 rows. In that case, what will happen? The student name Srinivas date of birth 10 times it will be repeated. It consumes unnecessarily this storage. If it is a 4 records, is fine. Take for example in the case of transaction table and all, right? So if you have billions of records, you are gone. This is also one of the reasons why we do the normalization, right? To eliminate the redundancy also, right? So we do this. So normal form takes care of that. So again, normal form doesn't takes care of that, right? So we need to split it logically. That's where we apply this logic, like the non-key column is fully functionally depend on the key column or not, right? So those kind of 2 normal form 3, everything will take care of that, right? We will have to follow all those 3 in order to make sure that we are not storing the data redundantly, and also it is not causing any kind of insertion anomaly error, right? So yeah. No, it is not primary key error, Deepak. See, Deepak, here student ID is 1, right? Let's say Srinivas has taken course ID, and Srinivas can take, he has attended another course, and 2, and Srinivas has taken, another thing as like, course 3. But here 1 is a composite primary key. Primary key can be more than 1 column also. In the interview, if they ask you, give me an example for composite key, you can say student ID and course ID. But don't tell student course in the interview. You have something called order ID. So order ID, they say in the transaction, right? So the transaction file, sales fact or order ID, or line key, right? So line number, something like that. For example, order ID 1, line number 1, 2, 3, and same thing. But the product ID, right? So each product, right? You would have purchased product A and B, C, right? So for that, they maintain this one. So they maybe this is a composite primary key here. Fine. So in the case of to address data, it causes some kind of data redundancy. Yeah, fine, right? So if you are able to understand Deepak, it is fine. So now what we do is, now the question is, okay, what should I do now? So it is violating the first normal form, first of all, and second one is this one. The second issue is redundancy. To introduce some kind of redundancy. If I keep the course ID along with this table, it is violating the normal form, first normal form. Or even if I duplicate this, redundancy, it leads to redundancy. Or can I keep the student ID somewhere here? Same issue. So for that reason, what we do is we will introduce something called bridge table. It is also called as a junction table. Bridge table or junction table. Okay, so what we do is we store the student ID and course ID together here. For example, Srinivas has taken course ID 1 and the same Srinivas is taken course ID 2, and the Deepak has taken course ID 2 math, and Radha has taken a course ID 1. Okay, and Radha as well took so if you see here, right, the student ID 1, it took these two courses, and a single student or we can say, let's I put so right, so here course ID 1 took by two different students, right, two different students, and then the these two, right, so these two has taken by these two different students, right, fine. So here a single student has taken more than one course, and each course is taken by more than one student. So this course is taken by more than one student, right? So we combine these two things together, student ID from this table and course ID from these two tables. We put it in a common table. This is called a bridge table or junction table. Now if you see the relationship between these two are one to many, this is one side and this is many side, and if you see the relationship between these two are, this is my one side, this is my many side. By introducing a bridge table, we are able to overcome that issue. If you ask me to display the student name and course name with the help of the bridge table, we can we can specify the course name, right? How do you write a SQL query here? How do you write a SQL query to display the course name along with the student name? So that we will see it later, because you need to know the joins, types of joins. First of all, you need to know what is inner join, what is outer join, left join, right? All those things you should be knowing it. Only when you know that, then you should be able to answer to this question. Okay. So you need to have this one. Supposing if I ask a question, right, how many number of courses taken by student 1? Since, right, you have had a bridge table here, you should be able to tell clearly, right? Student ID 1 has taken 2 courses here, and course ID 2 has took by how many number of students. If I ask that question, you can say, hey, these 2 students have taken that courses, right? You should be able to answer this one. Now if you I just shared the script here, right? Look here, that is why I shared the script here for many to many .sql, right? So that is the one I shared it here. Okay, many to many SQL. Create the table, right? So create the table, and why don't you try generating a query which displays for a given student ID what are the courses he has taken it. I want the student name and the course name, right? For a given student ID, it should give me that, and also for a given course ID, the student name should get displayed, right? So what are the student name for that course ID, it should get displayed, right? So one to many, right? So that is what I need to know. So why don't you write a query to join these 3 tables and do it. So those of you already familiar with the MySQL background, right, Oracle query background, you can give it a try. The table I have given here, give it a try. But those of you are still not clear about this one, right, don't worry, we will discuss tomorrow same time, okay, as an exception, right? Tomorrow also we'll have the class, and we will discuss about the joins, different joins. After that, right? So once you understand the joins, we will solve this one, right? We will display the student name along with the course name to display based on the student ID. If I wanted to see what are the courses he has taken it, right, we can select it and so in that case we need to join these three tables, remember that. So many to many relationship is one of the type of issue, or this is the scenario will often come across when you do the data warehouse model design. We will discuss about data warehouse also later point in time, the tomorrow session. Okay, we have something called additive measures, semi-additive measure, non-additive measures. You should be knowing this one. Okay, and in the interview they ask you questions related to non-additive measures, something like that. You should be knowing that. So for example, when I use the DAX functions like all, selected, all, except, keep, filter, keep. So in that kind of using which, how we can perform the non-additive related arithmetic operation. How do you do that, right? So semi-additive related arithmetic, how we do that. Non-additive, actually, as the name says, we cannot do any arithmetic operation, right? So you cannot add percentage of contribution or something like that. You cannot do that. Percentage or ratios, you cannot add them together, right? So you cannot perform that. Is called non-additive. Additive, as the name says, you can add values to that, and you can perform some kind of arithmetic operation with additive. And semi-additive is, as the name suggests, right, you can partially you can do it with example. Tomorrow will explain you, so that you will have a crystal clear idea on that. Many to many also we will see tomorrow. Okay, followed by this, after explaining the data warehouse concepts, right, we'll jump into the joins, and after you understand the joins, and we'll see how we can write a query to display the student name and course name for a given student, which course he has taken, everything. And then we will jump into the stored procedure, how to create a stored procedure, and how to create a function. All these things we'll take a look at it tomorrow. All right, any questions so far? So you might, for beginners, right, it might be little bit fast tracking. Don't worry, you watch my video one more time. If you are still not clear, will give some other examples. Okay, with some other example we'll take a deep dive. Don't worry. Okay, the normalization, if you know, it is good, because in the case of data warehouse we do denormalization only, star schema. Okay, we'll discuss that also tomorrow. I'll give you some kind of overview about that. At present you don't have to worry about star schema also, but I will give you an idea about that. But when I cover the data model relationship, everything as part of Power BI, we'll explain it in detail, including the many to many also. Don't worry. Yes, Deepak. One second. You can unmute yourself and talk, Deepak.
Sir, can you hear me, sir?
Yes, Deepak.
Sir,
Available in YouTube, right? We will discuss. We'll share the link. You can take a look at it. All right. Fine. Any other questions? Fine. We will continue the session tomorrow. All right. Okay. Take care.